Hey everybody, Codemaster X here. We're going to be doing an intro to C# class here. The first thing that we're going to need to do is we're going to have to get Visual Studio Community. You can download that from visualstudio.microsoft.com/vs/community. You hit download, and then it will run you through a visual setup. It's pretty easy. You want to make sure that you have the Universal Windows Platform Development, .NET desktop development, and desktop development with C++. Those are going to be the big things that you're going to need for everything that I'm going to be doing on this channel. So not just C#, but we're going to be doing C++ as well at some point in the future here. So those are the big three that you're going to need for this. And then from there, once you have it installed, you can go ahead and start it up, and it will look something like this. Probably will be smaller, it'll be something more like this. And so, yeah, let's create a project. We're going to be creating a console application. There are two, so don't get too confused here. There is the console app.NET framework, and there is the console app. We want just the console app. The nice thing about C# is that C# now natively runs on Windows, Mac, and Linux. And so if you do the .NET framework, then you're going to have to use something like Mono, the Mono runtime, to run it on Linux and Mac. But if you use this console app, which is .NET Core, which is what we're going to be learning, you won't have to worry about that, and it will run on Windows, Mac, and Linux without any, crazy stuff. So I'm going to go ahead and put this into my C# folder. I highly recommend when creating projects that you have a projects folder with the language that you're going to be using and then the name of the project. It makes it a lot easier to find things. So if you have just a projects folder with a bunch of stuff in it, you don't know what is what. So I usually have things in there: C#, Unity, Unreal Engine. So, depending on what I'm using, I have a subfolder inside of my projects, and then inside of those folders are my projects themselves. So we're going to call this Basics. We want to make sure that we're selecting the .NET 6.0 with long-term support. And then we're going to hit Create. And then we're going to wait for this to open. On some computers, this may take quite some time. As you can see, I'm actually lagging a little bit here while my computer kind of catches up. So this is a pretty heavy operation. But once it's loaded up, you should be totally fine. So the first thing that you'll see is it says Aka MS new console template. So this is the console template for a .NET application. Sorry, a .NET Core application. And so we're going to be running through the absolute bare bone basics for this. So that has been installing and setting up the project. And in the next one, we're going to be getting into variables and how to start making things a bit more dynamic. So thank you all so much for watching, and we'll see you guys in the next one. Peace, peace. All right, so that's the first video. That's the first video done. That's pretty much how to install it and get everything set up and ready for this next section of the course. So the next one, we're going to work on variables. All right, so 3, 2, 1. Hey everybody, Codemaster X here. In the last one, we learned how to create. In the last one, we learned how to create a project. We installed Visual Studio, and we created a project. So we downloaded it, installed it, created a project, and now we're going to learn how variables work. Variables, you can think of them as something of an alias. It's kind of like a name that you're assigning to a set of data. In C#, C# is what's known as a statically typed language or a strongly typed language, which means when we're creating a variable, we need to tell C# what type of data that variable is going to be holding. So in C#, there are a couple of types of variables, and on the Lowest level, we have strings, we have integers, we have floats, we have booleans, and we have void. Those are the what are known as primitives. And so we're going to be looking at the primitives first, and then we'll be looking at custom types in a later video, but let's worry about primitives first. So the first one we want to learn of is a string. So strings are essentially an array of characters, right? So if you're going to be typing in, and when I say characters, I don't mean characters in a video game. I mean characters as in individual things on the keyboard, right? So A, B, C, D, those are known as characters to a programming language. So if I say string name equals, and then I need to have a pair of double quotes. Double quotes means that this is a string. So if I say Mr. Codemaster X, then this string is holding the data Mr. Codemaster X. So let's actually display that to the screen. And we're going to be doing that with console.writeLine. That essentially just gives us the ability to write text to the console. And so as this boots up, this could take a couple of seconds here. It's basically loading everything that it needs to start running this application. And we see Mr. Codemaster X in the console. Now, the way that I did that was I added a $ here. This essentially is what's known as string interpolation. It allows us to take a string and then output our variables in a certain format. So if I wanted to do something like my name is, and then run this, then we see my name is Mr. Codemaster X. And so if you want to just output a variable, you don't need the string here. You can output a variable in the console.writeLine with just its name, but it must be a string. So if we hover over WriteLine, we see string value up at the top here. So up there, you see void console.writeLine string value. So as long as it's a string, you can output it, and we see that our variable is a string, and it is able to output it. So let's talk about numbers. You have two types of numbers. You have an integer, which is a whole number. So if we are trying to hold a whole number, we use an integer. And then the second type of number is a float. And that does things like 2.2. In C#, we have to put the F after it because in C#, we are broken up into two types of floats. You have a float and a double. A float is faster, it's more efficient, and it takes up less memory than a double. It is also less accurate. So as you start getting into math around floats, and as you start getting into the more, like the longer they are, so if you're like 2 point and then a bunch of numbers after that. So if we did something like pi, right? 3.14159.2, I think after that, those start becoming less and less accurate as it goes along with a float. With a double, it maintains accuracy, but it does so by consuming more memory. It's a little slower, and it's not as optimized as a float. These days, if you have a pretty decent computer, it really doesn't matter. As a matter of fact, the Unreal Engine just went from using floats as its primary to using doubles as its primary, because it allows the world to be much bigger, and it doesn't have those issues with larger numbers and that sort of thing. So that basically resolves the issue of floats being basically unreliable as they get larger, right? So the other one is a double. Oops. So if I did a double, let me go ahead and make this bigger so that everybody can read it. So we could just do 2.2 here, and you see that we don't get. So if I remove the F off of here, you see that we get an error. The F, again, just tells C# that it is a float and not a double. Again, we talked about the difference between floats and doubles. So I just named this FL number, float number, and DB double number, right? Just so that we're aware of my naming convention here. The next one is a bool. This is known as a boolean. This is essentially like a switch, on, off, right? So there are two possible values for a boolean, true and false, right? And that's what I mean by on, off, right? So if you want to think about it in terms of computer language, you all have heard about zeros and ones, right? That's literally what a boolean is, 0 or 1. 0 is false, 1 is true. So if you want to think about it, in terms of like the lowest level, it is basically some of the lowest level stuff you can work with. Boolean, literally 0 or 1. That is essentially our list of primitives. There is one more called void. Void means nothing, right? And we're going to be talking about that in not this video, not the next video, but the one after that. So let's explore our variables and how to work with them. So we can reassign any of our variables. That means if they're assigned to something, we can reassign them to something else. So for instance, we have Mr. Codemaster X here. And if I run this, we see it says Mr. Codemaster X in the console. But if I wanted to rename that and say Gene, so we have name equals Gene, and then if we run it, we see it says Gene in the console rather than Mr. Codemaster X. The reason for that is because we are reassigning the variable to something new. So our variables can be reassigned. There is a way to not reassign a variable. There's actually two ways in C#. The first way is to create a constant variable, and you'll see when I add the word const here, name becomes, has a squiggly and says the left-hand assignment must be a variable, property, or index, or local constant name is immutable. Immutable means that once it's set, we cannot reset it. And that's what a constant does. So if we want to make sure that our data being held in a variable is always the same data, we can create a constant variable. The other way of doing that is creating a read-only variable. These generally are only available within a class, but there is a way of creating a read-only variable, just so that we understand how to do that. So let's see how we can take in user input and change our variable. So console.readLine. If we kind of hover over this, it says read the next line of characters from the standard input stream, and we see it has a string question mark next to it. That means that is a string that could be null, and null is another primitive type. It basically means nothing. It's the same as void, except for null can be a placeholder for something. Void can never be a placeholder for anything. So if we want to say create a variable and initialize it, we can initialize it to null, which is a placeholder of nothing, right? And then we can then set our we can then reset the variable later. We can't do that with void. Void, for all intents and purposes, for this course, can never be anything but a return type from a function. Again, we'll talk about those two videos from now. So the way that we get our line, basically our text, into our variable is we say name equals. If you see variable equals something, that is what's known as an assignment operator. You're assigning data to that variable. And we want to basically tell our user what they're going to be doing. So we're going to say, please tell me your name. So now if I run this, we can see that I'm set to Mr. Codemaster X up here. We're writing a line that says, please tell me your name. And you can see that this is here. And we're assigning name to whatever our stuff is. So I can give it anything. So if I just do this and I hit enter, you can see that it then outputs what I input into the console. So that is how you set a variable using C#. Let's try and do something interesting. So let's say I want to output my number and I want to take in my number. Well, we'll see that console.writeLine is allowing us to do that because it does have an overload for numbers that it can take in. But our console read line says cannot implicitly convert type string to int. And that's what I mean when I say that C# is a statically or strongly typed language. We have to essentially cast... we essentially have to tell our variables what kind of data they can hold. Our number is an integer. It cannot hold a string. Therefore, when we're trying to set a string to our number, we can't do that. However, there is something that we can do. So let's say that we type a number into our, let's say that we're typing a number into our console and we want to create a number, or we want to get that number and put it into our number value. There is a way that we can do that. We can do that with int.parse. And so now you see that we no longer have those errors. The squiggly here is basically just telling me that this could possibly be null, and I'm not handling it could be null. We're not going to worry about that right now. We will talk about how to handle nulls in a later video. For now, just understand that that blue squiggly line is not red, which means it's not an error. It's just a warning, and we're going to be ignoring those warnings for now. We will be addressing those in a later video. So now if I go in here and I give it a 10 and I hit enter, we see now that it outputs 10 and our number is fine. Well, what happens if we go in here and we try and type something other than a number? Our program will actually crash and it says input string was not in the correct format. That essentially means that we didn't give it a number. We have to ensure that our variables are the correct format, and since it wasn't a number, it wasn't able to convert it into an integer and place it into our number. So we'll talk about how to handle that later, but just understand that is something that can happen if we're not making sure that the user input is what we're expecting. So you can also, of course, do the same thing. So if we wanted to get a float instead of an integer, we can see even though a float is a number, we cannot convert a float to an int. We can't implicitly do that, which essentially means that we can't. C# doesn't know how to just do it. We have to instruct it how to do it. There is a couple of ways we can do a cast modifier. So putting parentheses in front of something with a type in it casts that from one thing to another. Now, we remember that integers are whole numbers and floats are not. So what happens if I say 10.5? You see it just outputs 10. And the reason that it does that is when we cast it, it essentially floors the value. And that basically means it takes the point and removes it. That might not be the functionality that you want. So if you want to take a number and say round it, you have to use the math library. And we can do that with math.round. And now Um, you can see that this one is expecting a this one is basically expecting a double. Um, so we can cast it to a float, and again, um, it will tell us that we can't do that here. We can cast it to an int as well, but essentially, where round is putting out a double, we were, our variable is a float, so it's basically taking our float, rounding it, casting it to a double, and then we need to cast it to an integer. So if I do something like 10.5, now it's 10. And the reason that that is happening is because, again, we're kind of flooring it with int here. There is, there is overloads that allow us to take in floats and output integers and that sort of thing. We're not gonna worry about that right now, but essentially, we're pulling it. So we now know how to basically cast input into a number, and then we know that we can cast one thing to another. So the question here is, can I just cast my string directly directly to an integer? Unfortunately, no. Only certain types can be cast into each other, and right now it doesn't really understand how a string can be a number, because you could possibly have non-number things inside of a string. That's why we needed to do the int.parse, because you could possibly have things in that string. And we saw that if we did that with non-number characters in a string, that it created an error. So now we know about variables, how to set them, and how to create variables, how to set them, how to reassign them, and how to print them to the screen. That's going to be all for this one. In the next one, we'll talk about the meat and potatoes of programming, logic, and how logic works. But for now, I hope you guys kind of were able to follow along and understand what variables are, how, why they're useful, and why they're important, and why the types are important when it comes to C#. So again, remember, C# is a strongly typed language, or a statically typed language. So we need to make sure that our types are in order when we're using them, and that everything kind of meshes together properly. Again, thank you guys so much for watching, and I'll see you guys in the next one. Peace.